Look at this. I have taken a numerical problem from this book, Enjoy Science, published by JK Education Center, and I want to solve it. A rocket is fired from the Earth towards the Sun. At what point on its path is the gravitational force of the rocket J? Mass of Sun is given here, and mass of the Earth is also given, and orbital radius of the Earth is also given. This numerical problem is diagrammatically represented like this. We can represent this way. This is mass of the Earth, let's say m1, mass of the Sun is, let's say, m2, and distance between them, let's say d, and it is given. And let's say when the rocket reaches through this point, that is x, then the gravitational force of the Earth acting on the rocket will be neutralized by the gravitational force of the Sun acting in opposite direction on the rocket. So total distance is if d, then the distance between Sun and rocket will be d minus x. Okay, now I want to divide this into two parts. One, the gravitational force between Earth and the rocket, first part, and the gravitational force between Sun and the rocket, second part. And these two forces are equal. That's why I am making two equations to solve this numerical problem. The force between Earth and rocket can be written as F equal to Z, mass of Earth m1 into mass of the rocket m, and distance between the Earth and the rocket, that is x squared. On the other hand, the force between Sun and the rocket, can be represented this way. The gravitational force between Sun and rocket, F, is equal to G, mass of the Sun, mass of the rocket, and the distance between Sun and rocket, that is d minus x whole square. If we compare these two equations, then comparing equation 1 and 2, what can we write? If this gravitational force are equal and opposite, resultant is 0. So we can say that Z m1 m upon x square is equal to G m2 m upon d minus x whole square. Here G cancel, m also cancel, and remaining we can write, here we have m1, m2 can be taken to left hand side, m1 by m2, x square can be taken to right hand side, x square upon d minus x whole square, or m1 by m2 is equal to x upon d minus x whole square can be taken. If this square is cancelled, if this square is taken away, then we can put here root over m1 by m2 equal to x by d minus x. Now I want to put the value. This m1 is mass of Earth. That's why its value is 6 into 10 to the power 24, and m2 is mass of Sun. Its value is 2 into 10 to the power 30, and this is equal to x upon d minus x. I want to put this value of d also. Let's come to this place. Now 6 divided by 2 becomes 3, and 10 to the power 24 if taken to denominator, if 10 to the power 24 is taken to denominator, then 10 to the power 30 into 10 to the power minus 24, all this comes in root over. This is equal to x upon d minus x, or root over 3 upon 10 to the power 30 minus 24 becomes 10 to the power 6, and this is equal to x upon, now I want to put the value of d, distance between this Sun and the Earth is given as 1.5 into 10 to the power 11, there is minus x also. Okay, if the root is taken out, if the root is removed, then we will have 1.732, root over 3 equal to this, and 10 to the power 6 becomes what? 10 to the power 3. If root is removed. This is equal to x upon 1.5 into 10 to the power 11 minus x. Now look at this again. If we take this left hand side, we'll have 1.732 1.5 into 10 to the power 11 minus x. 10 to the power 3 is if taken to right hand side, 10 to the power 3x. Or if we multiply these two, then we'll have 2.598 if these two are multiplied into 10 to the power 11 remains same minus 1.732x. This is equal to, this is 10 to the power 3 means 1000x. Or if this quantity is taken right hand side, 2.598 is equal to 2.598 into 10 to the power 11 is equal to 1000x. If this is taken to right hand side, then we'll have plus 1.732x or 2.598 into 10 to the power 11 is equal to 1000 plus 1.732 becomes 1001.732x. And if this number is taken to the left hand side, 2.598 into 10 to the power 11 divided by 1001.732, then x. Then if this number is divided by this number, then we'll have 0.00259 if divided by this number, then into 10 to the power 11 is equal to, sorry, this is equal to x. Or if this point is taken to 3-digit right hand side, then we can write 2.59 into point is taken to 3-digit right hand side, that's why 10 to the power minus 3 into 10 to the power 11 equal to x. Therefore x is equal to 2.59 into 10 to the power 11 minus 3 becomes 10 to the power 8. Since x is distance, that's why its unit is meter. And we can say that when rocket reaches to a distance 2.59 into 10 to the power 8 meter, then the gravitational force between Earth and rocket and Sun and rocket will be equal and opposite, so resultant is 0.